This is the moment we made history by landing on a comet. 10 years ago, our Rosetta mission got up close and personal with a comet, landing a probe called Philae on the surface to directly study the properties of a comet for the first time ever. The mission was groundbreaking. It was only the 7th celestial object we have landed on before. It was an ambitious journey filled with many ups and downs, but we're getting ahead of ourselves. Let's take a look back at the mission 10 years on. Comets are large objects made of dust and ice that have elliptical orbits around the Sun, which stretch far out into the outer edges of the solar system. They are believed to be left over from when the planets formed, and scientists think they could hold the answers to how life formed on Earth, why we have water on Earth, and how the solar system evolved. You may recognise comets from their distinctive bright tail, caused by the Sun heating up the frozen comet's core as they head towards the inner solar system, leaving behind this bright streak of dust and gas. Most comets are too small and far away to see from Earth, even with some of the biggest telescopes. And when they do come close, their bright tail obscures our view of the actual comet itself, making it hard to see and study from Earth. That's where our Rosetta mission comes in. Rosetta was launched in March 2004 on one of our Ariane 5 rockets. From here, it set off on its 10-year-long journey to Comet 67P Churyumov-Gerasimenko. The comet was chosen as it originated in the Kuiper belt, but does not venture out much farther than Jupiter anymore, making it perfect to align with Rosetta's journey. However, the journey was anything but simple. Rosetta required some energy boosts along the way, starting with a gravity assist of Earth, just a year after launch, which sent the spacecraft on towards Mars for another boost. From here, Rosetta came back to Earth before passing by the diamond-shaped asteroid CNES, and returning back to Earth for one final boost. Rosetta then got on its way to deeper space, flying past the huge ancient rock Lutetia, grabbing photos and data along the way. After all of this excitement, as Rosetta travelled on farther from the Sun, it did not have enough solar power to operate fully, so was put into standby mode, sending the spacecraft into a 2-year, 7-month and 12-day slumber. In January 2014, the world sent Rosetta a wake-up call, and the team got sent to work to make sure all the instruments on board were working after the long break. The spacecraft still had 10 more manoeuvres to perform to align it correctly with the comet, and to get it to the right speed so it would be captured by the comet's gravity and not be flung off into space. As Rosetta approached Comet 67P, scientists spotted something unusual. The team expected to see that the central part of the comet, its nucleus, is sort of shaped like a potato, but instead, the images Rosetta sent back resembled more of a rubber duck shape. It had 2 lobes, almost as if the 2 comets had slammed into each other and bonded. It looked like nothing we had ever examined in the solar system before. This made landing Philae a bit more complicated. The complex shape of the comet made for a complex gravity and a strange rotation situation, which made flying around it very complicated. There were also craters, cliffs, sinkholes and boulders the size of houses which had to be taken into account. Rosetta spent a few weeks analysing the comet, sending back information so the experts could determine where was best to land. Typically, landing sites, for example on Mars, take years to select, so for Philae it happened exceptionally fast. No lander had attempted to make a soft landing on a comet before, so there was a lot at stake. Finally, the experts decided on the perfect landing spot for Philae, and the probe was sent down, and the world held its breath for 7 hours to hear if the spacecraft landed successfully. Touchdown was confirmed at 17:03 Central European Time on the 12th of November. But there was something strange about the data returned. Soon scientists, flight dynamics specialists and engineers concluded that Philae did not just touch down once on the comet, but 3 times. The harpoons that were meant to dig Philae into the comet's surface securely had not fired, and the lander appeared to be rotating after the first touchdown. And then the lander lifted from the surface for 1 hour and 50 minutes. During that time, it travelled about 1 kilometre at a speed of 38 centimetres per second. It then made a smaller second hop, travelling at about 3 centimetres per second, and landing in its final resting place 7 minutes later. This left Philae in an awkward angle, but it was still able to conduct its onboard experiments and send data back down to us here on Earth. However, the landing spot had limited sunlight, meaning the solar panels could not be charged, and Philae eventually lost power after 57 hours. In the end, about 80% of the planned science was completed. Not bad considering the circumstances. Meanwhile, Rosetta continued to study the environment of the comet, studying the dust particles which flew off as it became more active on its approach to the Sun, and monitored the changes on the surface. After 211 days, Rosetta noticed a strange signal. Scientists analysed the data and realised Philae had woken up after 7 months in hibernation. Engineers determined that Philae was exposed to sufficient sunlight to heat it to an acceptable operating temperature and to generate electricity. This allowed for the experts to home in on the final resting place of Philae and allow us to say a final goodbye. After becoming the first spacecraft to orbit a comet and the first to deploy a lander, Philae, in November 2014, Rosetta continued to monitor the comet's evolution, surviving the harsh environment of the comet for 786 days, making a few dramatic flybys close to its surface, surviving several unexpected outbursts from the comet, and recovered from 2 spacecraft safe modes. After almost 2 years in operation around the comet and 12 years in space, Rosetta's own mission would also come to an end on the surface of the comet, with a controlled impact. Confirmation of the end of the mission arrived at our control centre at 13:19 Central European Summertime, with the loss of Rosetta's signal upon impact. The descent gave Rosetta the opportunity to study the comet right up until its last moments. The world may have said goodbye to Rosetta, but its legacy will not be forgotten. Rosetta changed our view of how the solar system formed, how the planets were made, and gave a glimpse at how life could have begun here on Earth.